Naveen.
Okay. So where did we end the session last night, guys? Where did we conclude the session yesterday? Did I talk about classes, class A, B, C, D, and E? And what's the relevance of each class? Did we cover that yesterday? What is class A? What is class B? What is class C? We covered this, right? Who all were there in the session yesterday? I think Amit was there. HNS was there. Lakshmi Naidu was there. Sara, you were there. Tasleem was there. Sirisha was there. Sahu, I think you joined a bit late last night. If I remember correctly. Right. Okay, cool. So yeah, let's get started without any further ado. In today's class, we're going to start with a new topic called subnet mask. Now, when I open up my command prompt, so if I open up my command prompt here, and in my command prompt, if I type ipconfig, you can notice it provides me three pieces of information. First, it shows me my exact private IP. So right now, my system is getting the IP 192.168.0.5. Okay, that's the private IP assigned to my system through the Wi-Fi adapter. Now, below that, you can see there's something called subnet mask. Okay, and there's also something called default gateway. So let's talk about these today. Okay, so now when you talk about subnet mask, guys, this is for the computer or any information system to understand which class they belong to. Now, for example, us humans can know which IP belongs to which class from the network and host portions. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. So we get to know that from the alphabets N and H. But how does an information system or how does a computer get to know which IP belongs to which class and how many network or host portions it has? So for that, the computer makes that identification by assigning the network portion bits with the value of 1 and the host portion bits with the value of 0. Okay. So subnet mask is, again, it is used to determine network and host ranges with an IP address. Okay. And it consists of consecutive 1 and 0 bits. Okay. All the network portions identify as with 1 bits and the host portions identify with the 0 bits. Now, when you take the example of class A, it has one network portion and three host portions. So all ones in the first portion and all zeros in the last three portions. And now when you convert that from binary to decimal, what do you get? All ones is 255 and all zeros is 0.0.0. Okay. So for class A, the subnet mask is 255000. Okay. So when this subnet mask is assigned to a system, it gets to know, okay, so my network is a class A network and I can connect a maximum of 255 into 255 into 255 devices. That's the entire range of class A. Okay. When you talk about class B now, two network and two host portions. So 255, 25500. And for class C, with three network portions and one host portion, subnet mask is 255, 255, 2550. And if you clearly observe here, the IP that I was getting in my command prompt was 192.168.0.5. And if you remember, this is a class C IP. And since it is class C, the subnet mask is 255, 255, 2550. Exactly what I have here. Okay. So from the subnet mask, my computer knows, okay, so since I belong to class C now, the maximum number of devices I can connect are 255 devices. Okay, not more than that. So it knows the starting range and the last range of IPs. Okay. And the default gateway. Now, this is a fancy name given to your Wi-Fi router. Okay, so because if you notice this diagram here, which I used in the earlier sessions, your router acts as the gateway between the private network and the public network. When any of these devices wants to send a packet to the internet, they always have to send it to the Wi-Fi router first. And that Wi-Fi router forwards that packet to the internet. So it is acting as a gateway here, connecting the intranet devices with the internet devices. Hence the name default gateway. And your device needs to know what the default gateway's IP is. Unless until it knows that it doesn't know whom to send the packets to send it to the internet. Okay. So that's what these other two pieces of information mean. Subnet mask tells the IP, tells the computer what its range of IPs it can connect with, which class it belongs to. And the default gateway tells the router's IP, telling it who the who the packet should be sent to if the packet needs to go to the internet. Okay. So that's what subnet mask and default gateway are for. Okay. Any questions, any doubts regarding that? Amit, HNS, Arnav, Lakshmi Naidu, Saikat. Lakshmu Naidu. Okay. Sara, Sheikh Tasleem, Sirisha, Samantha Kumar Sahu.
Could you explain the default gateway, please? As this is the first class of mine.
Oh, Cycle, this is your first class. No worries
Yes.
again. If you again before that, Cycle, just in case if you want to get access to the earlier classes, you can go to the official website of no, not sorry, not official website, the official channel of DurgaSoft on YouTube. So I think it's called DurgaSoft Training Online or something. Okay, so you can go to that channel and you can get the earlier videos as well, just in case if you want a recap of the earlier sessions, which I took from Monday. Coming back to the topic of default gateway, as mentioned, your home has a Wi-Fi router, and that Wi-Fi router acts as a gateway to connect to the internet. Okay, so when your phones, your laptops, your smartwatches, or whatever device they be, when they want to communicate with the internet, they have to send the packet to the Wi-Fi router first when they're connected to the Wi-Fi network. Okay, and from the Wi-Fi router it goes to the internet, and from the internet to the so and so websites. Okay, so default gateway is basically the name given to the Wi-Fi router, telling that this is the default device which is acting as the gateway to connect to internet and vice versa. Okay. Is that clear, Cycle?
Yes, yes, yes.
Right. Now, moving forward, let's talk about the next discussion, which is how to assign an IP address. So again, when you talk about assigning an IP, guys, there are two techniques to it. One, you can assign it manually from the control panel yourself, or you can get it automatically from a DHCP server as well. So in order to assign it to yourself manually, there's a certain technique, a certain procedure, and this is the procedure as follows. Okay, so you go to your control panel, then you go to network and internet, network and sharing center, change adapter settings, right click on the adapter properties, IPv4 properties, and assign the following IP. Lengthy, I know, but let me show this practically as well. So first things first, go to your control panel. Search for control panel, click on control panel here. In control panel, you go to network and internet. As you can see, next thing is network and internet. So click on network and internet here. In this, you go to network and sharing center. In network and sharing center, you go to change adapter settings. So on the left side, you have this option here. And this shows the list of all adapters on your system. And whichever adapter you want to change or modify the IP for, right click on that adapter, go to the properties, and in the properties, select Internet Protocol version 4 properties, IPv4 properties. And now you get the option here. So right now I'm getting an IP automatically, which is from my DHCP server. But if I had to assign my own IP, I have to select the second option here and assign the IP address of my choice. So again, those three same pieces of information are required. IP address first, okay, then the subnet mask for it. So since I'm assigning class C IP, subnet mask will be 255.255.255.0. And default gateway is my router's IP, 192.168.0.1, the first IP in the network. Okay. And along with that, it is also asking one more piece of information. Give me the DNS server address. Now, just in case, if you don't know what to enter here, go to your browser. And oh, the browser is not available. Let me open up a browser first. And in your browser, just quickly search for Google DNS server IP. And that is going to provide you two IP addresses, guys. One is 8.8.8.8, and the other one is 8.8.4.4. And you can use any one of them. So if you type 8.8.8.8, that should be perfectly fine. Or alternatively, you can give 8.8.4.4 as well. Even if you mention one of them, that is also fine. Okay. Now, don't worry what a DNS server is. I'm going to cover that as well. Okay. But for now, just in case if you want to know what to enter here, these are the default IPs to enter. Okay. And when I click on OK, now my IP address will change to 0.100. Okay. Right now, I'm not going to do that, guys, because when I change my IP, our connection might get disconnected. Okay. So our meeting might disconnect. So let's not interrupt that. Okay. So now let me talk about the other procedure. How does my system get an IP automatically? Okay, so if it's a small network, you can assign an IP yourself. So if they're like 5, 10 devices, you can go to each system and assign a manual IP this way yourself. But if it's a large network, let's say 100, 200 devices, going to each system and assigning an IP is quite a hectic task. That's why we have something called a DHCP server. Okay. So this is private IP, correct? Yes, again, Sumanta, 192.168. If you remember, that belongs to the class C private IP range, right? So this is definitely a private IP. We cannot assign public IPs. Please note, public IPs are only assigned by the ISP, Internet Service Provider. So to my Wi-Fi router, whichever ISP I'm connected to, Airtel or Act Hibernate or whatever it is, those people assign me a public IP. I cannot assign the public IP myself. Okay. The only thing I can change is in my local network, I can assign a private IP to each system, each unique device. Okay. Is that clear, everyone? Right.
Yes.
Assuming it's clear. Moving forward. Now, what does this option do? When I click on this option, obtain an IP address automatically, how am I getting that IP automatically is the question, right? So to understand DHCP, it's a very simple protocol. It stands for Dynamic Host Configuration Protocol. So if I go to my browser and search for DHCP, you can see it's called Dynamic Host Configuration Protocol. From the name itself, we can figure out what it does. It is used to dynamically or automatically configure an IP address to every host in the network. Okay, so it is used to automatically assign a unique IP to every system that is connected in your network. How does it do that? It happens with something called the DORA process. Okay, so to explain DORA, let me use a simple diagram. Okay, so again, bear my terrible drawing skills. So let's assume over here we have our DHCP server. In our home networks now, you might ask, where is the DHCP server? So in our home networks, our Wi-Fi router itself acts as a DHCP server. Okay. So in our home network, Wi-Fi or DHCP server is same device. Okay. And this gets the first IP. So 192.168.0.1 is assigned to the router or the DHCP server. And your DHCP server has a pool of free IPs. Okay, and from this pool only, it assigns each IP to each unique system. So now the pool begins at the next IP, 0.2, then you have 0.3, then 0.4, 0.5, etc., etc., goes up to the last IP, 0.254. Okay, now whenever there are devices connected in this network, this DHCP server assigns an IP to each of those devices, okay, with the DORA process. So the process called DORA, D-O-R-A, it assigns each unique system a unique IP from the pool. So this gets 0.2, this gets 0.3, etc., etc. Okay. And whenever those IPs are assigned to the system, those IPs are removed from the pool. So now the pool now should begin at the next IP, 0.4. This becomes 0.5 now, and so on and so forth. Okay, because now if you still have the IP in the pool, it will assign it to one more device that will cause a conflict. So whenever an IP is assigned, it is removed from the pool automatically. Okay. Now let's say I bring one more device in the network. Okay. So now let's talk about DORA. So firstly, when you connect a new device to the network and when it is selected on that option, obtain an IP address automatically, what this device does now is it starts broadcasting a signal. So what I mean by broadcasting is a packet is sent to every device in the network. Okay. So one from one to all is called broadcasting. Okay. Now you might ask, how is that possible? So if you remember, there's an IP, one more IP left out, 192.168.0.255. This IP is called the broadcast IP. So whenever a packet is sent to this IP, it is sent to every other IP in the network. Okay, that's what broadcasting means. So that IP is called the broadcast IP and it is never assigned to any other system because its purpose is to act as a broadcast signal. Okay, when a packet is sent to that IP, it is sent to every other device in the network. Okay, so this broadcast packet is called the discover packet, guys. Oh, sorry. So this is called the discover packet. So the main job of this packet is to discover where the DHCP server is. So it's asking every system, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? When it reaches the wrong systems, they just discard that packet. They don't respond to it at all. Okay. But when it reaches the correct DHCP server, that server responds back saying, hi, I'm the DHCP server. And now I can offer you an IP address back. So now it makes an offer saying, hey, thanks for finding me out. And now I can offer you a new IP from my pool, let's say 0.4. Okay. So once that offer is made, your client gets very happy and it says, oh, thanks. Thanks for offering me that IP. And I want to make a request that you do not assign it to anyone else. Since I asked you first, you offered that IP to me itself, you assign it to me. So now a request is made from your client to the server saying, hey, Do not assign it to anyone else. I dare you. Just assign that IP to my system and no one else. Okay. And for that request, your DHCP server client kindly obliges. Okay. And it says, okay, I assign this IP to you now. And this is my confirmation for it, also commonly known as acknowledgement. Okay. So acknowledgement is like the confirmation saying, hey, I acknowledge your request. And now this is my IP to you. With that acknowledgement, this device now gets that IP successfully, 192.168.0.4. Okay. And this entire process is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. And all of this happens very spontaneously, like in 1 or 2 seconds, max to max, not more than that. Okay. And I'm pretty sure you might have observed this at least once in your life. Whenever you connect your phone to the Wi-Fi router, for a very short duration after you enter the password, it shows a message obtaining IP address. I'm not sure how many of you have ever seen that. Okay. But whenever you see that message obtaining IP address, your phone now is communicating with the router and it's performing the DORA. And after that DORA is done, then it shows connected. Connected in the sense your system has now got a private IP and it can start communicating. So that is where the DORA occurs. After you enter the password, it performs the DORA and it assigns a private IP to you. Okay. So that's what DHCP server does, automatically assigns an IP to each system in the network. Okay. And yeah, I have this thing available here as well in the presentation slides. D for discover, O for offer, R for request, and A for acknowledgement, DORA. Okay. Any questions, any doubts up to this point? Anyone? Amit, Saikat, HNS, Lakshmi Naidu, Arnav, Sara, Sheikh Tasleem, Sirisha, Shivasai, Sumanta Kumar Sahu. Okay. Right. Assuming no questions, let's move forward to DNS servers. Okay. So now when you talk about a DNS server, one second, guys, let me just get some water. Right. So when you talk about a DNS server, guys, now this in a simple definition is like your internet's phone book. Okay. So just like how we have a contacts app in our phone, what does a contacts app do? It links a contact number with a contact name, right? So we humans are terrible at remembering huge series of numbers, right? So again, even if you have my number as well, so you might have saved it with a certain name, Shoaib cybersecurity trainer or DURGASOFT trainer or whatever it is. Okay. Next time, whenever you want to call up my number, you search with that name itself, right? Because you don't remember the number. You don't have to. You again, the contacts app makes it easier for you to link every contact number with a name. Okay. And you search by that name and you dial it up, right? But the question that arises here is it relevant what you save the contact name as? Okay. To make the connection now, the only requirement is your 10-digit number and my 10-digit number. Okay. What you save the number as is, again, it's your choice. You can save it as Shoaib, cybersecurity trainer, DurgaSoft trainer, whatever it is. Okay. The connection is not being made here on the name. It's being made from your 10-digit number to my 10-digit number when you initiate a call, right? Similarly, when you go to your browser, and in your browser, when you go and you search for a URL like www.google.com, your browser actually doesn't understand this language. It doesn't know what google.com means. It doesn't understand these alphabets because every time you need to make a connection on the internet, it happens on public IPs. So from your Wi-Fi router, which is getting a public IP, it needs to connect to Google's server, which is having its own unique public IP. Okay. But where does my browser get to know that information? What is Google's public IP? That is provided by a DNS server. Okay. So the DNS server is like the internet's phone book, translating human readable domain names into IP addresses. When you type a URL in your browser, that request now first goes to a DNS server. So from your server, I mean, from your system's browser, it goes to the ISP first. Your ISP has a DNS server, And in that DNS server, it has information called records. Okay. And in each of those records, there's a linking. So there's a linking with every domain name to its corresponding IP. So google.com stored on so-and-so IP. Bing.com stored on so-and-so IP. YouTube.com stored on so-and-so IP. Show.com stored on so-and-so IP. So basically, every record consists of a linking between a domain name with its corresponding IP. And from that IP address, now it reaches the correct server. So the request is sent to the Google server. Okay. So that is what a DNS server does. It translates human readable domain names into IP addresses. If there were no DNS servers, your browser would never have understood this language, www.google.com. It would have asked you to enter IPs, exact IP of the server. Okay. So whenever you enter the domain name here, this request goes to a DNS server. Then it translates your domain name to its exact IP and then sends the request. If I show you this practically, I can go to my command prompt and I can run a simple command here called ping, P-I-N-G. Okay. So ping is a command to check for connectivity actually. So if you type ping and a domain like www.google.com, what it does now is it sends some packets to that server, okay, from my device. These packets are called ICMP packets, okay. And I think it's called internet control messaging protocol or something. Okay. But basically it sends 4 packets now from your system, ICMP packets, and it waits for a response. And you can see for each of the packets sent, there are responses as well. So 4 packets were sent and those 4 packets got a reply back as well, which means everything is perfectly fine. You're able to communicate with that server and there's 0 packet loss, which means your connection is perfect. Okay. But if you notice over here, when I'm pinging to Google, I'm getting a response back from an IP here, 172, 270, 166, 100. So if I copy that IP and if I go to my browser and if I paste it over here, carefully observe what happens when I hit enter. This loads google.com. So this was the actual IP of the server on which the Google web page is hosted. Okay. But luckily, we don't need to remember that, all thanks to a DNS server. So a DNS server maintains a record linking this exact domain name, this exact IP. Okay. If there were no domain DNS servers, we would have to enter each of these IPs for every website. Okay. And definitely we can't remember all those. Okay. So we remember a domain name, and with that domain name, we connect to the website. Okay. And internally, that domain name gets converted to this IP exactly. Okay, and the connection is made. Okay, so that's what a DNS server is. Okay, now when you're assigning your own DNS server, if you remember when we were assigning our own IP, I searched for something like Google DNS server. So Google, this company, which hosts the Google search engine, has its own DNS servers. Okay, it has 2 DNS servers hosted on these exact public IPs, 8.8.8.8 and 8.8.4.4. So these are globally available DNS servers, available again for free. So anyone can use these DNS servers. Okay. So whenever you want to connect to the internet and when you want to make these DNS connections or again DNS requests, you can use these IPs for free. Okay. So again, that is what a DNS server does, guys, translating human readable domain names into exact IP addresses. Okay. Is that clear? Any questions, any doubts about what a DNS server does?
Uh, I have one question. That
Yes.
is, DNS server is provided by the ISP, but there are multiple ISP are available. So every ISP are connected with every ISP provider. Like if
Yeah,
I
again, they
create
can
any,
have their own unique DNS server cycle. So there's no necessary that all of them have to share one DNS server. So they can have their own individual DNS servers, and all of these are interconnected on the internet. So if their DNS server does not have that info, what their DNS server will do is it will send the request or forward that request to another DNS server on the internet, the closest one. It could belong to another ISP. So that information is shared from one server to the other server freely. Okay.
okay, okay.
All right. Okay. So yeah, that's what a DNS server does. Okay. Moving forward to the next topic, we have now special IPs. So in your entire range of IPs from 0000 to 255, 255, 255, 255, there are 2 special IPs. Now these IPs are neither private IPs nor public IPs. They are not used for connections. They're only used for troubleshooting. Okay. So the first special IP you have is loopback IPs, and they range from the number 127.0.0.0 to 127.255.255.255. And this whole entire range of IPs holds only one single purpose: to check if your NIC card is functioning properly or not. Now, what is an NIC card? So if you go to your browser, if you search for NIC over here, it stands for Network Interface Controller card. Oh, sorry. It's better if I add card in the end. Yeah, better. So now, if I open up any of these images, this is what an NIC card typically looks like. Okay. So if you're connected on a laptop or so, if your laptop has an Ethernet port like this, right beside that Ethernet port, you have this NIC card connected. Doesn't mean that if you don't have an Ethernet port, you won't have the chip. It just means you don't have the Ethernet port. But still, this chip will be available on every system. Okay. So, and this chip is responsible for all your network connections. Okay. So all the networking components, networking interfaces are placed on this one single chip itself. So the hardware components of your interfaces, Ethernet interface, Wi-Fi chip interface, what Bluetooth interface, whatever it be, all the networking physical components of those interfaces are present on this one single chip. Okay. And if this chip fails or if it starts malfunctioning, your system will not be able to communicate with other devices. It cannot retrieve an IP, it cannot send any packets, nothing at all. Okay. And just to verify if your NIC card is working properly or not, you have the loopback IP. Okay. How do you use this loopback IP to check that now? So all you have to do is go to your command prompt and use the same command again, ping, and you can use any IP from the entire loopback range. So you can type 127.0.0.1 or 127.123.45.56. Any random IP will work. Okay. The only condition is the first octet should be 127. Okay. So in the entire range, you can use any IP. Okay. And when you hit enter, you should get a response back. If you're not getting a response, it means your NIC card is not responding. It's not functioning properly. Okay. But if you do get a response, everything is perfect and everyone's happy. Okay. So basically, as mentioned, that's the only single purpose of loopback. The reason why it is called loopback is again pretty obvious. You're trying to ping back to your own system. You're forming a loop over there. You're connecting back to your device and forming a loop. Hence the name loopback. Okay. So that's what loopback stands for. Okay. Moving forward, then there's the next IP called APIPA. It stands for Automatic Private IP Assigned Address. And this ranges from the number 169.254.0.0 to 169.254.255.255. Okay. Now, this is a special case IP which is assigned to your system in a scenario where your system is unable to retrieve a private IP from any other source. So let's say if your system is not getting an IP from DHCP server, and neither is it getting manually from you as well. In such a scenario, your device gets an APIPA IP. Okay, that is assigned by the operating system. Whatever operating system you use, whether it be Windows or Linux or whatever it is, that operating system itself will assign the IP to your device. Okay, and that IP is the APIPA IP, an automatic private IP assigned in a scenario where you cannot get an IP from any other source. Okay, even your DHCP server or manually as well. Okay, so that's APIPA. Okay, so these two IPs are only to indicate if everything is perfectly fine or not with your network. Loopback is to check your NIC card, and APIPA, if APIPA is assigned to your system, it means something is wrong in your network and you have to see to it that your system gets an IP from other sources. Okay, so that's about loopback and APIPA. Okay, there's one more topic left out called CIDR. I'm going to cover this in the next session, guys. So this is the last topic. We'll hold this for tomorrow. A small assignment for you is you can try to do some research and get me information on what CIDR is, okay, in the next class. And again, any one of you can answer this in the next session. What is CIDR? Okay, and we'll talk about this in the next session along with the lab setup installation. So again, please note, tomorrow will be the last class for the demo, guys. Tomorrow will be a practical session. So I'm going to show you how to install VMware. So again, this is the application required for the lab setup. It's a virtualization software. It allows you to install multiple other operating systems in one singular device. So I'm going to show you how to install VMware, how to install this operating system called Kali Linux. Okay. So that's going to be the class tomorrow, a practical session, understanding how do we create the lab setup for the upcoming days. Okay. So that's what we're going to talk about tomorrow. Again, a very important session tomorrow, actually. So a practical session. Please do join without fail. And as mentioned, tomorrow's class is going to be the last class for demos. No further demos will be assigned. Only for the registered students will be continuing this course from Monday onwards. Okay. I have Kali Linux in my system. I don't have Windows, but I need Windows for this course. Oh, yeah. Sumanta Kumar Sahu, we might need Windows definitely. So again, some practicals that we work on, we try to attack a Windows operating system. So for that, you would need Windows. So yeah, okay. Can you please share the recording link? Oh, it should be available on YouTube, guys. Okay, let me search it myself as well. I think it's on my email as well. Let me check. Yeah, you can filter it out. So you can search for DURGASOFT cybersecurity, filter with recently uploaded, and you can see they're all demos. Demo 1, Demo 2, Demo 3. Okay. So this was Demo 1 taken 2 days ago or so. Then Demo 2, then Demo 3. All the classes in the last week taken up. Okay. So you can search for this from here, guys. Let me drop this in the chat box. So again, please note, as mentioned, there will be no more demo sessions after tomorrow. Tomorrow is the last demo session. So if you haven't registered already, please do register, guys, as mentioned. PIPA is for what? Again, as mentioned, Sarah, a PIPA is basically an IP address assigned automatically by your OS. So it tells you that your system is unable to get an IP from other sources. So you have to check why is it not getting an IP from other sources. So it's just an indication that your system did not get an IP from any other source, automatically assigned by the OS itself. Is that clear? Yeah. And yeah, that's that. Nothing further for our session tonight. We can exit the session here. And let's connect back tomorrow for our last demo session. Please do register at the earliest, guys. From Monday, the link will change. I'm supposed to inform that. Okay. Bye-bye. Good night. See you tomorrow at the same time. I have a device having multiple NICs. That's an interesting question. I've never heard of such a device again, Cycle. You can actually, I
Yeah.
think you can, but
It,
usually your systems come with one inbuilt NIC. But if you want, you can add multiple as well, definitely.
okay. Okay.
Right. Depends on if
And
your system
just
has the
small
slot
question.
available. Oh, sorry, come again.
Can I ask you just a small question?
Yeah, yeah, yeah. Yeah, all questions are welcome.
Hello. Yeah. So in the market, I see there are different types of courses available. Like someone saying the SOC, CM, so so if you just inform that what is the difference between them or how can I start this thing, then it will be good. Like
Good question again.
given a
Again,
kind of
to
idea.
answer your question,
Is your
Cycle.
course related to like SOC or?
No, yeah, I'm going to answer that. So your entire infrastructure of cybersecurity is divided into departments. There's something called a SOC and there's something called as NOC. SOC stands for Security Operations Center. Okay, and in SOC you use something called SIM tools, SIEM tools, Security Incident and Event Management tools. Okay, these tools are capable of monitoring and logging all the information coming in or going out of your organization. So basically, they are used to monitor and analyze traffic. Okay, live traffic coming in or going out. That's SOC. We cover a part of it in this course. Our course is mostly focused towards NOC, Network Operations Center. So in your organization, no matter what devices they be, whether it be as small as a mobile phone to as big as a web application server or a database, firewalls, again, your Wi-Fi routers, your mobile phones, your Windows or Linux operating system devices, whatever it be, your job as a cybersecurity professional in NOC, Network Operations Center, is to check that these devices don't contain any loopholes, any vulnerabilities, okay? Misconfigurations or vulnerabilities in the source code, bugs in the source code, etc., etc. Okay. So our job in NOC is to find loopholes on any of these devices, check them from time to time. And if they do exist, how do you remediate them? How do you remove those loopholes? So that's called NOC. Okay. So our course is mostly focused on NOC and a part of SOC. Okay. So we'll be covering 80%. knock, and 20% SOC, I can say. Okay. So as a cybersecurity professional, as a fresher getting into cybersecurity, there are more job roles towards the knock department, towards penetration testing. But we can't leave out SOC as well. So we'll be covering a part of it. And I definitely will be sharing much more advanced resources on SOC as well. Okay. Some tools or videos or whatever related to Splunk. Splunk is a SIM tool, SIEM tool. Okay. So yeah, if you need information on SOC, I can provide that as well. But to be frank and upfront, we'll be working on mostly on NOC department, Network Operations Center. Okay, right. Will we be doing simulation training or
Yes.
virtual
Thank
simulation?
you.
Again, we will be doing virtual simulations itself, Sarah, because again, as mentioned, we'll be working on virtual machines. So me having an exact practical simulation of an organization might not be possible. So I won't be having other servers, other physical servers or anything. I use the same configuration of those servers virtually. So in my Kali, in my VMware virtualization software setup, I'll install multiple different other operating systems and I'll show you how to test the security of each and every endpoint, whether it be a Windows system or a Linux system or a web server or a web application as well. Okay, is that clear, Sarah? Okay, it will be virtually available on one single device itself. Okay,
Yes.
which will replicate the scenario of an organization. Right.
Yeah.
Uh,
Thank you.
sure. Thank you. Any other questions, guys? Sarah, I hope I have clarified your question. Is this course sufficient for application security engineer, or we have to do other course of this? Application security engineer. Which application again? Mobile application, web application. Again, this will not be covering advanced topics from web pen testing, Sumanta, sorry, my bad, Sahu. So again, I teach a course separately for students who are interested in web security. So this covers only up to intermediate level, as mentioned, guys. So no matter what pen testing it be, network or web or your mobile or whatever it be, you cover only up to intermediate level. After this course is done, you can choose one of those domains and specialize in them. So my specialty is in web pen testing itself. Okay. So again, for information on that, you can contact me directly, Sam. But you do need to go through another course for web security specifically. Okay, an advanced course. Okay. So yeah, that's that. So again, just give you a brief intro on that. So when you talk about web security, it involves something called OWASP Top 10. So OWASP stands for Open Web Application. There's static in your mic, so I've muted you. So you can text me if there's anything. I've muted you manually. There's a lot of static. Okay. But again, as mentioned, when you talk about web pen testing, there's something called OWASP Top 10, which deals with top 10 vulnerabilities that are, again, according to survey, the most important ones in today's world. Okay. So your job as a web pen tester is to see to it that these top 10 vulnerabilities don't exist in websites. In this CH course, we won't be covering all the top 10. We'll cover one or two. Okay. But to learn all the top 10, there's another course called Web Application Pen Testing. That's something that I provide privately to students who are interested after CH is done. Okay. But to go to that, you need to complete CH first. All the technicalities, all the fundamentals are covered in CH. And again, everything from the basics. So those basics are not covered in Web Pen Testing Advanced course. So you have to go with that. CH first and then web. What is the account number to make the payment? I think it has been mentioned here, right, Sarah, by DurgaSoft online in the chat box. So let me copy and paste that same message again. If you scroll up in the chat box, actually, I think it's mentioned here. Mm, 1 second, let me copy that message and paste it as well. Mm, yeah, I've dropped that message in the chat box. Oh, I think I need to drop it to all. 1 second. Yeah. in this message from DurgaSoft, you have the bank account details, the phone pay numbers, Google Pay numbers, or whatnot to make the payment to the institute. Okay. So if you want to register, you can contact those phone numbers in the chat, or you can also make the payment on those account numbers and send them a screenshot, okay, on those numbers. And they'll confirm your payment and you can get registered. Okay. Is that clear, guys? Sarah, Samantha Kumar Sahu. Any other questions, anyone? Arnav, Lakshmi Naidu, Manju Patil, Saikat, Sheikh Tasleem, Sirisha, Shivasai, Shirkul. Okay. Has everyone noted down those details, guys? The account number details or whatnot? If you have, I can exit the session and we can connect back tomorrow at the same time to take up the last demo session. Sarah, have you noted it down? You asked for the details.
I have. Yes. Thank you so much.
Perfect. Right. So yeah, that's nothing further for our session today. We can exit the session here and connect back tomorrow at the same. Oh, Sheikh Tasleem. Yeah, you've dropped a message in the chat. No, Sheikh Tasleem, we don't go. I don't teach malware analysis. So again, that comes in something called forensics, computer forensics, and malware analysis. I don't teach that. But again, in this course, we talk about creating malwares and defending from them. So how do you create viruses? How do you create Trojan applications? And how do you detect them if they're already installed in your system and hidden in your system? And how do you defend your system from those malwares? We won't be going through the analysis and understanding how to create them. Yeah, that's what. Again, we won't be going with those tools. Sheikh Tasleem. Saikat, you can go through the earlier demo recordings actually to answer that question. So I've mentioned what all topics we'll be covering throughout the course. Okay, and we'll be covering the entire syllabus that is mentioned in the official EC Council web page. Okay, but to get much better idea, you can go through demo 1, the class recording which is uploaded here. And in that class, I've mentioned specifically what topics we'll be learning throughout the course. Okay, one by one.
Okay. Thanks.
Sure. This goes, what kind of job roles can I apply? Again, you can, I think I've answered that question as well earlier, Arnab. You can apply for, again, security analyst, junior security analyst, or again, certified ethical hacker, penetration tester, security consultant. These are all the job roles you can apply for. Right. Any other questions, guys? Again, Sheikh Tasleem, as mentioned, we won't be working with that too. We won't be covering malware analysis. Again, an intro on what malwares are, how do you create these malwares, how do you defend your system from these malwares as well. Okay, nothing related to malware analysis. Exactly. Right. So yeah, that's that. Nothing else for today's class. Let's exit the session here and connect back tomorrow at the same time. Bye-bye. Good night. See you tomorrow.
Thank you.
Thank you, guys. Bye.